welcome to another problem session. So today I have a interesting problem for you, and actually it's probably very geared towards the medical field. So when you jump, so this is the picture here I want you to kind of focus on. Okay, so that's the picture. I could write in story, but picture is better. So you are on some platform over here and you jump from here to another platform. Your center of mass go from here to about here. So you jumped about this edge, and when you hit this, you are going to have a bend your knee or something. So during you first have a contact, and then as you lower your body, so your CM is going to come down to delta H, this much. So at this time, it's before hit, its speed is V, but after some time, it lower your body, and it comes to rest. So there's a before collision, and then there's after collision. So this motion has two parts. One is just freely falling, and then another is during the collision part. Okay, so there's two parts to this motion. So the question is during the collision. So this is the question, is that during this process of slowing down after hitting and coming to rest, there will be force from the ground on you, normal force, and that normal force, so this is actually the normal force from the ground, and we're supposed to figure out what the average will be, average in time. So I mean, it probably before you hit it was nothing, and then suddenly it peaked up, and maybe as you relaxed, it's more like this. So it's pretty high here, and that's where the probably bone breaks. Okay, but we're gonna just do that average. This problem is about the average, and this profile is not given to you, so what function will be. You can model things like that. If you like, you can make this problem a little more interesting by saying that, hey, what's the peak force going to be if this is a maybe this kind of triangle, maybe 1/3 of the time is like this and comes down, and another 2/3 of the time is like that. So you can model like that and make it more interesting, but I'm not going to do that, but just questions about average. And so that's find the force, average force, and use this average force to find the pressure on the ankle bones. Now you can do we can do it like assuming two things: that you are really stiff, you came down hard on the ground and you hardly moved during that, so like you just moved maybe just 1 centimeter, just teeny bits. Okay, you were so stiff. Now that's going to be, you would say, that's the most pressure causing thing. Another one will be you're kind of a little bit flexible and agile, and you kind of, when the moment you touch the ground, and it's kind of, it's natural for humans and all the animals to slow their body, bring the bodies to rest at a lower ground. Okay, lower center of mass. And say you delta H was 10 centimeter, your center of mass moved that much. This is during the collision. So these two assumptions, let's do them out. Okay, so I will do with the delta H. I'll keep all this same and put the numbers at the end. So two parts. So let's see what the B will be. So it has two parts of the motion. So two parts, right? I mean, really very important to follow the motion in time. And you're going to know it's really two parts. So first part is free fall. So we're just looking at vertical speed is 0 here, horizontal vertical speed 0 here. You may say, how come this guy got this going right side? Or you might give this guy horizontal speeds. So v along, this is the x, this is the y. We're not really interested in this detail of this. You can just say he just was over here and it fell straight down. If you prefer, this diagram is just for drawing thing. I will say you're here at this platform here and you straight fell down from 0 to that. We're going to assume that to make it simpler, okay? So free fall. So v was 0, v0 was 0, then we just need to figure out, and it has fallen, delta y is h, and ay is minus g. So v will be, of course, over there will be negative. So v, because h, so you could have the v square equal v0 square plus 2ay delta y, right? So delta y is negative, this is 0. So this is minus, you have a 2 minus g minus h. This actually will be negative because you start from here. So say this y equals 0, then y is up positive, then it's going to be negative h over here. So the v is square root 2gh speed wise, and it's going down like that. So this is vy will be negative square root 2gh. It's sometimes helpful to have all these positive negatives right, but sometimes not. It's probably can be sloppy here, and probably is okay. And I'm sometimes sloppy in here because it's so simple problem. So that's this. It's going down like this. So this is before collision. So now the second part is during collision. So collision is between the floor, which is kind of infinite mass, and you. So this is the before collision, you're going square root 2gh. Okay, this is the speed before, and then you are here, but I mean you're touching this center mass. So v after is 0, and between time between this to this is delta t. Okay, so and so force during this time, force is upward, is F average. So it looks like we can do change of momentum along the y-axis is F y delta t average. So this is change of momentum along y-axis is equal to y impulse. At this point, I'll even take the y-axis is this way, right? So this just becomes f, whatever this f average over there I wrote down, f average, and delta t is the amount of time it took. Final is 0. Initial is going down, so minus So this is the final, and this is the initial minus m square 2gh. So it just tells me, let me move this up a little bit. So already gives me f average is going to be m square root of 2gh over delta t. So everything is given here. Cg is given, h is given, delta t is given. Okay. If delta t is not given, then you can actually find the delta t, because if delta h is given, delta t amount of time is not given here, so we can actually find the delta t. So let's say this is not given. It will be related to delta h, right? So in between this time and this time, so we have a here. So this is the cm at t equals to t, and t equals to t plus delta t, and so the velocity is this way and velocity is 0, acceleration is that way. Acceleration is f average over m, so that's the acceleration. So if this is the vy, and if this is the distance delta h, then you can see v, so it's kind of related to v with a delta h, right? So can you see that this acceleration and this delta h? So the v will also be related with in this where this becomes a 0 in the end, right? So how can we relate this guy with that and figure out delta t, how much time it took to come to rest? So v equal to v0 minus f average over m delta t. So this goes to 0. So this is v0 for this part, and this is the v0 here. So this one is that v over there that we found, square 2gh. So 0 equals square 2gh f average over m delta t. And so you can actually get this delta t from here, square 2gh m over f. So you have exactly the same thing. You can actually get it from here also, right? So there are other ways of getting it. Let me look at how you're gonna get delta t. How to get this delta t from delta h, in which your cm comes to rest. So how you can do it? So you can do v square. So this, let's call this v, let's call it v final, and the vi just to distinguish. V final square equals v initial square minus 2 times this acceleration times delta h. So this is 0 equals to vi square was 2 gh from before, minus 2 times a is this f av over m, so you can just use that, f av over m delta h, and you can see the delta h. So you can say f av delta h is just 2 goes away because of 0. So gh on the other side, side, and then MGH. So this is the work done, and that's the change in potential energy. That's another way to think about it. So you have a, if you have a F ab delta T is this one, and so if I just divide this, so delta H will be, delta H over delta T will be mgh over m square root of 2gh. M cancels out, so we got the delta T out. Delta T is delta H square root 2gh over gh, or you can say square root 2 delta H square root of gh. So we got delta T here in terms of delta H, and we can plug in here and we can get F ab. So F ab, or we could have just gone here F ab. So I just want to show you that you can get through the delta T. All of this is kind of related. I hope everything is consistent, hopefully. So I would just use this. Even if I don't shown, you can go to delta T. I can just use this. Let's go back to remain on track, okay? So m square 2gh, and this is square root of 2 delta H over square root of gh. So this is m gh over delta H, which is the same as over here. So our F ab is just mgh over delta H. You could have gotten this just if you thought were energy and work done by external forces. So this is another way to really shortcut you could gotten it. Okay, so that answers how to get the force. If I assume for average force, how to get the pressure on the ankle bones, and then we can put the numbers. Okay, so that's one formula. So here is the bottom of the maybe the heel that touches. So I'm going to put just one place. Maybe you touch both feet, but together the net area is A. And force is applying on all this, the entire thing. So F average. So if multiply F average times A, that will give me the pressure. And this pressure will be compressive pressure on the bone. So that's the pressure will be mgh over delta H times the area. Let's see what this number come out. Okay, so we see we just need to figure out mgh. M is 70 kilogram for this person. G is 10 meter per second square, and H was 2 meter. Delta H was 1 centimeter when it's stiff, and another case was 10 centimeters. So we need to convert that in meter, 0.1 meter, and this is 0.1 meter. And A was given as 5 centimeters square. Then that will be 5 times 10 to minus 1, 10 minus 2 meter times 10 to minus 2 meters, 10 minus 4. So 5 times 10 to the power minus 4 meters square. I see this double conversion often causes problem for students. That's why I did this, although I knew the students for right away. Okay, so so if so case A, not much bending, right? What do we get? F average I got is 70 kilogram times 10 times 2 divided by 10 to the power minus 2. This 10 to minus 2. and this is 10 to the power minus 1. So 14, 10 to the power 2, and 2 is 4 Newton, or 1.4 times 10 to the power 5 Newton. And case B, if you had bent more, so this is the B case, and this is the A case. In the B case, this will be 10 minus 1, so F average will be just 10 times as much. 1.4 times 10 to the power 4 Newton, 1/10, yeah. Okay, how about the pressure? Pressure will be 1.4 times 10 to the power 5 in terms of Newton, and delta H is 5 times 10 to the power minus 4 Newton. So this is roughly 0.3 times 10 to the power is 3 times 10 to the power of Newton over meter square. This is meter square. 8 Pascal. And of course, it's bigger than 2 times 10 to the power 8 Pascal. And so it will break. And the bone that will break is the ankle. That's the weakest there. That's the most pressure again. It's going to break there. And in this case, pressure is going to 1.4 times 10 to the power 4 Newton, but downstairs is same. 5 times 10 to the power minus 4 meters square. So this is 3 times 10 to the power 7 Pascal. And this is less than 2 times 10 to the power 8 Pascal. So this is when bone not break. So this is a simple illustration of how nature has actually found an instinct to embed in all the animals. When they jump, they're instinctively, after contact, they move their center of mass by bending and deforming their bodies, so the impact does not cause this harm to the body. So this is very interesting, actually, very interesting biological fact. Okay, so this was a pretty instructive problem. Okay, I wanted to just say that if you like this kind of detailed explanations and discussions of physics problems and how to solve it, the strategies that sometimes you have to use, approximations you may have to make sometimes, and how to interpret physics problems in general, you can check out this website fully, subscribe to this channel, and tell your friends and maybe your teacher or something, tell other people to check this channel out. Tell your friends. Thank you, and take care, and bye.